When we enter the EMS, it all starts with the analysis of the process. To analyze the process, Celonis extracts digital footprints in real time from the source systems to render a full digital twin of our key processes. With this X-ray, we can easily track passenger, flights, or luggage from the booking to the landing of the flight based on our existing transactional and user interaction data. However, these are only the most common steps. When adding the next most frequent activities, we discover deviation from our standard process, and we start to see different paths in our turnaround or connection process. Celonis uses its multi-event log functionality to visualize how the different process connects and interacts with each other, which allows us to identify hidden inefficiencies between them. As we expand the process to its fullest, we can see the real complexity of our processes. How can we make sense of this complexity? For this, we're going to take the role of Anna, our ground operations manager. Celonis is already providing her with an overview of her main objectives and KPIs, on-time performance, connectivity, and cost reduction. Anna can quickly see that her on-time performance has decreased over the last month and is far from her target. With this information, she is going to ask Clara, her process analyst, to investigate what is impacting the on-time performance and how she can improve it. When Clara enters the deep dive of on-time performance, she sees the turnaround process that she can easily explore on the left and her main KPIs regarding departure and arrival delays on the right. Thanks to machine learning and a deep dive of historical data, Celonis is already highlighting the main inefficiencies and is calculating the impact that these have on the process. We're going to focus now on the first inefficiency, as it is the one with the most impact: long turnaround. Long turnarounds impact our on-time performance, causing delays in the departure of flights as well as in the deboarding of passengers that are now more likely to miss their connections. All of this impacts not only on customer satisfaction, but it may also cost us a slot or force us to speed up the plane during the flight. Celonis also shows us which are the turnaround activities with the longest time compared to their target time, and quickly highlights that the root cause for the most of the delays are linked to boarding, fueling, or deboarding. Celonis can also filter on the activities that fall under our providers' responsibilities to better understand the impact in terms of average at the time per flight due to delayed activities from our suppliers in the turnaround. With this information, Clara wants to accelerate these activities that are delaying the flights, and for this, she's going to use an action flow. An action flow is an automation tool that allows us to trigger automated actions based on intelligence, historical data, machine learning, and business rules that Clara herself can establish. It works via API, and analyzing the process, it automatically launches an action to correct an undesired deviation when one is found in our process. In this case, Clara wants to build an action flow to accelerate turnaround activities and avoid delays. For this, she is creating a Celonis module to detect flights that usually have delays in departure. Then it identifies the most common activity that is causing the delay, and afterwards, it updates the transactional system with a more appropriate starting time to ensure that even if the activity takes longer, with an earlier initial time, the flight will still depart on time. Finally, it sends an email to the corresponding manager or supplier to ensure they are updated with the new changes. Let's now see how Celonis can help Clara monitor the connection process, gaining visibility end-to-end on the main metrics, find the main gaps and bottlenecks, and act to correct those in real time. In this first dashboard, we can find the most relevant KPIs: the number of passengers with connections, the number of passengers missing their connections, and the current connectivity ratio. Plus, Celonis also provides an overview of the connection flow, namely aggregated information on where our passengers are coming from and where they're flying to when they have a connection in the Lisbon hub. The thickness of the line indicates the amount of passengers involved in the connection, but the color reveals where we are having problems with connectivity, as our misconnection ratio is high. We can see, for example, that for flights coming from Amsterdam and then moving internally in Portugal, we currently have a misconnection ratio of 9%, affecting more than 30,000 passengers. We can also check the evolution over time of misconnected passenger by month or even by day or hour if needed. We can detect seasonality or improvement compared to previous periods. For example, we can see a high number of misconnected passenger in August, and we can now filter on this month, and we can notice that we have problems across our main connections, such as New York, Lisbon, Lisbon, Paris. If needed, Clara can also get into more detail and get an analysis for specific connections. She can set up tables like the one below, where she could see the relevant metrics for each single connection and see where the airline is having problems. In this case, Celonis, using real-time data, already highlights those connections where we are constantly having delays and where the scheduled connection time is not respected. When we have such high differences between the scheduled time a connection should last and how long it actually lasts in reality, we could take strategic decisions to better improve our flight planning. For that, we can use again an action flow. With this specific action flow, Celonis detects the connection time planned by TAP for a specific connection and then analyzes whether that time is respected or not and calculates the difference between the schedule and the actual time of connection. If this difference is higher than a certain threshold, then Celonis will create a task for the ground operation manager, Anna, for her to review the case and decide whether to update the reference time in order to adjust it to the reality and avoid misconnection. If the actual time is found to be constantly lower than the scheduled time, Celonis will update it automatically for next month's flight plan and inform the manager via email, sharing with her a complete report automatically created in Excel. Now that we've seen how we can strategically improve our planning, let's look at how Celonis identifies other bottlenecks along the process. Analyzing millions of records and historical data, Celonis can detect patterns in the different variants and identify the main inefficiencies in the connection process, and also the impact they are having in terms of time added to the process. We can see that misconnections can arise because of a delay of the arrival flight, or when the flight has actually landed because bus arrives late to pick up passengers, or also from the moment in which the passenger get to the terminal, there could be several bottlenecks causing a longer connection time. That is, in this case, increasing the throughput time of the process of more than 51 minutes. We could get into more detail of a couple of them. For example, in the late arrival of bus, we can see the passengers affected and the impact in terms of additional time added to the connection, and also the potential improvement in time that we could obtain by tackling this inefficiency. As we did before, we can track the evolution over time of the delay and also cross it with the misconnected ratio to identify correlations and impact. Celonis also identifies the root cause behind these inefficiencies, such as the lack of available buses at a certain time or the congestion at the terminal as our bus overlaps with other. For each of these root causes, we can check the impact on delays on arrival flights as well as departing flights. Let's now deep dive into the connection time longer than usual. With the data point and the event logs available, Celonis can measure the time between the moment in which the passenger gets to the terminal after deboarding and the moment in which he or she reaches the gate for the connection flight. We can see the impact in terms of average connecting time and in monetary terms. And Celonis already identifies the attributes related to passengers or patterns of activity that are associated to longer times of connection, such as high presence of non-Schengen passenger in our flights that need to pass security and border control, or peak hours when several flights and thus passengers are landing at the same time, or having a backseat which delays the deboarding compared to people in first row when the plane is parked at a gate with an air bridge. Let's see now how Celonis not only provides visibility on the main bottlenecks, but also empowers the ground operation team in their day-to-day work. For that, the ground operation team can build an action view where Celonis provides us a prioritized list of all passengers with a connection at risk. Here we can see all the relevant information regarding the arrival flight, potential delays, the connecting flight, and the departure time, and compare the actual available time for the passenger to get to the connection, considering current conditions updated in real time, and the predicted time needed by the passenger to reach the connection. As computer, thanks to Celonis machine learning capabilities, taking into account all relevant fields and process behavior in similar conditions. With this prediction in mind, we are able to take action to guarantee connections for our passengers or to protect them as soon as possible. We can see, for example, that Teresa is arriving with the flight from New York with 30 minutes delay, and considering her seat, the position of the arrival and departure gate, the number of passengers overlapping at border control, Celonis predicts that she might not arrive on time for a connection. At that point, we can take a decision whether to keep the passenger on board and prioritize her in her next steps, or slightly delay the connection flight to allow passenger coming from New York to make their connection, or offload the passenger and look for an alternative flight. Connecting to all our system, Celonis already provides us with an alternative flight with TAP scheduled for later that night, where we have 3 available seats. However, it seems that she will have to wait a long time in the airport, and therefore a voucher needs to be provided. Otherwise, if we don't like this flight, we can look for an alternative flight directly on Amadeus. This operational view can help quickly address the most urgent cases. However, it could be highly manual to review all of the connection, while Clara could implement a business logic in our automated workflow to deal automatically with clear cases while involving humans only when their expertise really needs to be used. In this case, the action flow that we have here helps us predict the actual connection time needed by each passenger to reach its connection flight, and compares the potential delay with the scheduled departure time of the connection flight. If there is a difference of less than an established threshold, let's suppose 10 minutes, then the passenger can still make the connection if we manage to prioritize them. So Celonis automatically decides to keep the passenger on board, but organizes the ground operations PCAP to speed up and prioritize these passengers, and also send all the relevant information about the gate of the connection flight directly to the passengers for them not to waste any time once in the airport, and also inform the ground operation team via Slack for them to act as fast as possible. On the other hand, if the difference in time is too much, is too high, more than 30 minutes, for example, then Celonis will offload the passenger automatically, look for an alternative flight in our systems, and send it to the passenger and organize the standard voucher for its meal. However, when the predicted delay is between 10 and 30 minutes in a gray area, then Celonis creates a task for the employee in the ground operations team and alert them via SMS for them to review the case and use their expertise on these specific cases. In this way, we managed to automate part of the flow while allowing for TAP's employees to only focus on the relevant cases where their attention is really required. Now we have seen how Celonis can help in turnaround and connectivity. However, all these processes have a direct impact on protection and compensation costs. Celonis can also help you monitor these costs per type of protection, as well as compare it with our target. Also, it empowers us to run a deeper analysis to better understand, for example, the type of passengers that end up receiving higher compensation to ensure we can set preventive actions and avoid the additional costs. Thank you.